Okay, so just a crude demonstration of so just a basic demonstration to show that this has low friction. So, okay. Yeah, I think that was about 15 or so. Try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's gradually turning that way, so something's not quite level, is it? Not sure what it is I need to. If I turn this in a little bit more, see if that makes a difference. Try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, so it's 15 every time, isn't it? Nothing's changing. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Exactly the same every time, of course. I'll do it this time without talking over it. I think I shall now add the extra weight. So it was already 2 kilograms. It was already 2 kilograms. So now I've weighted it down another 2 kilograms. Again, I think that was 10, almost 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 versus 15. I'm sure somebody who's good at mathematics can work something out from that about the ratio when we've doubled the mass, because I'm guessing it's that 0.707 thing, isn't it now? I'm guessing that's going to work out at 0.707 of the speed, the velocity rather, when it was half this mass. I'm guessing. Do it one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just about 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Yeah, okay. 11 versus 15 before, wasn't it? I'm quite surprised to find out that that 0.707 thing actually worked out quite well. So there clearly is an RMS type, root mean squared type relationship between the ratios of these two different test runs carrying two different masses. I don't know why though, because I'm no good at mathematics. I'm in no position to explain it all. But it is a kind of an instinctive thing, isn't it? Really, that this RMS value, the root mean squared, it's the same with electricity. It's not the average value, is it? It's the root mean squared value. Interesting though, isn't it? That it follows this law quite precisely as far as we can determine. So I've just done the calculation, divided 15.5 because the trolley always ends up half. It's always 15 and a half, really, isn't it? So I've divided 15.5 because the trolley always ends up halfway across on the 15th run, after the 15th run. Then divided by 11, and that works out to 0.709. I'm quite surprised how close that is to 0.707, the RMS thing, the root mean squared value. I wish I knew the mathematics, to be honest. It's too late in life for me to take on all that, really, to be honest. I should have learnt it when I was a kid, and I didn't. I think that's Gary's downfall, the same as me, really. So I think people who are good at mathematics tend to have an easier time of comprehending all these relationships. To me, it comes as a bit of a surprise. It's a new thing for me. I'm learning as I go, but there's a limit how much I want to learn about this subject. I'm only really getting into this really just to challenge Gary's nonsense. That's the only reason I'm doing this. I'm not really particularly interested in the laws of mechanics. It's not really my fascination. It's interesting up to a point, don't get me wrong, but I don't want to make a study of it. I don't want to sit there for hours, doing exercises. Should I do the calculation just to show you? So 11, it was pretty much exactly 11, wasn't it? The number of runs between these 2 points when it was 4 kilograms total weight, total mass, divided by 15.5, because that was the almost always, I think, or always the result when it was 2 kilograms, which equals 0.709, I think. Put my glasses on to check. I've already done it once, but yeah. Yeah, 0.7096. That's lovely and close to 0.707. I'm quite pleased about that. I don't know why, but there you go. 0.707. I'm quite pleased about that. So sometimes it is instinctive, isn't it?